Dear ladies and gentlemen, welcome to today's webinar, Mine Planning in 3D Made Easier with New RIEGL Tools. Thank you for joining us today during these strange times of Corona, but I think it gives us a good possibility to transport information via these new modern channels. So about the schedule for this hour, I would like to start with a few questions asking you. Just answer with yes and no. This gives me a little bit better understanding how you are using the scanner or how you would like to use the scanner. Thereafter, I will present the webinar, and I hope in the end we will have a few minutes, let's say around 10 minutes, for questions and answers. So let's start with the few questions. First question: has your company already integrated your RIEGL scanner into a computer network? So please click on yes or no so that we get some information how you are using the scanner. I give you just around 10 seconds more to answer. Then we step to the next question. Okay, let us close this question. And very interesting, are 21% of the audience yes, and the majority is on no. I must say I've expected this answer. So let us step to the next question. Are you already using specific apps provided by your RIEGL VZ-I series scanner? Again, just yes. Sorry, I have to start it. So now, are you already using specific apps provided by your RIEGL VZ-I series scanner? Okay, let us close it. And now see the answers. Okay, the minority, just 10% of you are using apps. The majority have not used them. Sorry, I have here some sound. Okay, next question. Are you interested in working with real-time scan data on mines? Real-time scan data means real-time process data, which gives you directly after scanning results to make decisions on these results. Are you interested in that? Okay, just a few more seconds. Let's close it. And that's really interesting. Yes, the majority of you is interested in such real-time data, but on the other side, the majority is not using apps. So this is an interesting answer, but maybe after this webinar, you have learned more than how to use apps and how to get real-time scan data. So let us switch to the last. Sorry, I have not shown you the result. So you see 90% are interested in using real-time data, so the majority. So finally, our last question. Are you interested in remote control of your RIEGL BZI series scanner? Remote control means not just 10 meters away from the scanner with wireless. It means really remote. So the scanner is outside in the field and you are sitting in an office or in the headquarters, hundreds of miles, thousands of miles away and operating the system. Okay, we are closing this question. And again, a very interesting distribution of answers. So the majority is interested in remote control. So this is really good news for me. It sounds as if you're really interested in the content of that webinar. And so let's start now with our webinar. The topic of today, I will speak about the latest RIEGL hard and software developments to optimize terrestrial laser scanning for mine planning workflows. If we have not enough time for question and answers in the end, you see here also for detailed questions the email address info@rieglusa.com. So if we cannot answer in the end, please just send us an email. RIEGL USA will also forward your questions to me so that I can directly answer. So the content of today, we will start very quickly with a quick overview on the scanner portfolio for mining. Thereafter, I will highlight RIEGL hardware and software news for mining. And then in the second part of the webinar, we will speak about how can RIEGL support, let me just move this window a little bit, how can RIEGL support future trends in mining? Two main topics, how to embed RIEGL hardware into a mine computer network. And the other thing, utilizing mining apps for the RIEGL BZI series scanners. That comes together with the questions before, remote control, computer network, running apps, delivering directory results. So this is the second part of the webinar. Okay, let's start with our TLS portfolio for mining. Most of you know already the two scanners, the RIEGL BZ4000 scanner for extreme long range applications with a maximum range of 4 kilometers, and the RIEGL BZ2000i scanner with a maximum range of 2.5 kilometer range. These scanners are running in different static setups for sporadic, periodic, or permanent data acquisition. You see here on the left side the typical setup for sporadic data acquisition with a simple tripod, while we are using for periodic and permanent data acquisition pillars or concrete pillars, and for 24/7 operation we even have our protective housings to protect the scanner against really harsh environments, extreme cold temperatures, snow, ice, fog, rain. So with these protective housings, you can really work with the scanners in an extreme environment. So you see the protective housings here. And yeah, you see here a typical setup. So with such a setup, we cover the whole pit normally with these long-range scanners only from a few scan positions, like shown here, from 5 scan positions, acquiring long-range data, joining the scans with the automatic registration together, and getting the whole pit from just a few single scan positions. But now with the new VZ2000i, this is an extreme fast scanner. So it can do a single scan within 30 seconds, full 360-degree scan. So more and more customers are not only doing these few scan positions, they do real, we call it stop and go scanning. They mount the scanner on the vehicle, they stop the vehicle, doing a 30-second scan, and then starting the vehicle, go 50 meters forward and doing the next scan position. With automatic registration at the end of the data acquisition, the whole data is already registered. And this is really important. So instead of doing just a few single scan positions, we can do hundreds of scan positions, but the big benefit is no surveyor has to go out of the car. It's a safety issue. You see on the image here on the left side, the vehicle just goes in the typical harsh environment with the big loaders around, and you can do the data acquisition also in this situation because nobody has to go out of the car. And this VZ2000i scanner can be also integrated in our RIEGL BMZ system, which is a full mobile laser scan system with a high-end IMU and GNSS system. And in that combination, then the scanner is really doing data acquisition while driving directly in real time. So this is an optional feature. So let us speak a few words about RIEGL data quality and working under harsh conditions, which is standard in mining. We don't have a clean environment. We have harsh conditions. We have dust, we have rain, we have fog, and the hardware is protected against water and dust with an IP rating of 64, so you cannot damage the hardware. But what about the scan data which you acquire in such an environment? And maybe you have already heard the term full waveform data processing, which means we are sending not only one single laser shot, we're sending a single laser shot, but we can get up to 15 targets on a single laser shot. And you see that on here on the left side of this slide, some example on top here, a mine in Siberia with foggy conditions, snow. So you see we get all these reflections from the fog. In the middle here, heavy rainfalls. So we have these water particles scanned, and on the bottom here, a very typical situation for stop and go scanning in a mining environment. You see the scanner is here mounted on the vehicle, and we have a big dust cloud, which is produced by the tires of the vehicle, and we start immediately the scanning when stopping the car, so we cannot wait till the dust has gone away. So we detect all these things, but with the multiple target capability, we still have the data behind, and we can automatically filter this data. You see here now the dust and the rain is highlighted, and if we remove it, we have all the data behind these particles. So we can get a clean point cloud even in such a harsh environment. We are using full waveform data processing also to penetrate vegetations and also other objects like wires. Here an example, safety wires. You see the target classification on the right side. Single returns means there was only one single return, like it is normal in classical laser scanning. But with the multiple target capability, we have classified first targets. These are the wires and the tops of the trees. We have last targets, dark blue, and we have targets in between. As I already mentioned, we can get up to 15 targets on a single laser shot. And if we show this slice of data from the side, we see now the strong penetration on top of the trees, the first targets, then in between the trees, the other targets, and a strong penetration down to the ground. And also here on the bottom, we can detect the safety wires, but we have this whole situation, behind the wires. And this is really an outstanding characterism of our hardware and software, which can automatically filter these objects. So this about data quality and working in harsh conditions, but you see there is one problem with the whole system. It is the camera on top. I mean, these Nikon cameras which we are using, they provide fantastic images, but it's not really made for harsh conditions. And therefore, we developed a new camera, the new RIEGL VZI 20M heavy-duty camera. It has the same IP rating like the scanner, IP rating 64, so it's full waterproofed, dust-proofed, can work under extreme temperatures, and it's using the same connectors as the Nikon camera on top. So you don't have to change anything on the scanner. You can just, for example, if you are already a RIEGL customer and you're operating already a scanner, you can buy this new camera, mount it on the scanner, and with a firmware upgrade, you can operate it directly in the same way as the Nikon camera via the graphical user interface of the scanner. We see here the technical data. The weight is 1.2 kilogram, IP64, I mentioned already, and the wide operation, temperature operation range from extreme cold to extreme high temperatures. The sensor data, it's a 20 megapixel camera with a field of view 40 degree in horizontal and almost 60 degree in vertical direction. So to cover the whole 360 degree field of view of the scanner, we need 10 images. Of course, on top of this camera, you can mount your standard GNSS receiver. So we have the standard screw on top here, which is very smart because it provides a very stable connection between GNSS, camera, and scanner. And if you don't use the camera, we have also developed a new GNSS adapter, because we have seen in the past from mining operations that the older GNSS adapter was a bottleneck in the connection between GNSS and scanner, because sometimes this adapter was broken and then also the screw on top of the scanner was broken. The result was that the scanner had to be shipped back to Austria, repaired. So it was lost for a couple of weeks. So this was a big problem. But now with this new GNSS adapter, which is using the same mounting screws as the cameras, we have a very stable connection between GNSS and scanner, and no part of the scanner can be damaged in case something is broken on top of the scanner. So this is really also an advantage with this new mounting adapter. So far about hardware. Now let's speak about software and tools. And I want to mention on this slide that we can now really use reflector prisms as targets. In the past, prisms with scanners were always a problem. And we simply know in a mining environment, you can have hundreds of prisms around and you cannot avoid the prisms and you don't know where they are exactly. So in the very beginning, prisms have even damaged some of our scanners because they are reflecting all the laser energy back, and the detector inside the scanner is simply not made for such high amplitude values. We have copied nature to protect the scanner. So what happens, for example, if you look with your eyes into the sun, you have an inbuilt reflex that you will immediately close your eyes to protect your eyes. And the same we do on the scanner. As soon as a extreme high amplitude value comes back, we switch off the detector for some milliseconds to protect the scanner. So we have here a typical scan prisms. So you see here is a building. Here we are 4 prisms. And sometimes, if the amplitude values are too high, we switch off the detector of the scanner, and then we have this typical blue line underneath the target or on top of the target. But this is nothing wrong. It's just to avoid damage on the scanner, and after some milliseconds, we open the detector again, and you have your data. And the important thing is, once we do a fine scanning of the target, the scanner automatically reduces the laser power dramatically, so that nothing can happen to the scanner, and we get then really exact data on the prisms. You can now, within RIEGL Pro, really define your prism or reflector models. You can define the shape of the reflector, in this case a prism. You can define the diameter, also the prism or reflector constant. The same you can do on the graphical user interface of the scanner also. And within RIEGL Pro, you can copy reflector models from the software onto the scanner or from the scanner to the software. But the biggest advantage of these new reflector models, which we are defining on the scanner and inside the software, is that we fit these models into the point cloud, and we get an estimation how good the model fits into the point cloud, and this gives us a new attribute on each and every fine scan. And if you open the type point list on the scan position, you find now a new attribute called quality, and you see immediately the quality of each and every fine scan target. So if there is low quality, it simply means that either a wrong reflector model was chosen, or maybe that something was simply wrong with the fine scan, that the target was not fully scanned, that there were also some metallic parts with high reflectance around the target. This often happens. So this is reducing the quality of this fine scan, and you as a user, you can now simply filter out low quality type points and delete them and not using them for post-processing. So this is now really a big advantage. One of our customers has tested the prism models and the accuracy on a well-defined test area. So they have mounted the scanner on a concrete pillar, another concrete pillar with a mounted prism, and they know exactly the range, 1,200.0404 meters. And they have fine scanned this prism the whole day from 7 o'clock in the morning till 7 p.m. in the evening. And you see on that long range, the range accuracy was within a few millimeters. And what we also see is that underneath we have here the curve of the temperature during the day, and we see here a big correlation between the accuracy on the range data with the temperatures. So it seems that the atmospheric correction was not applied correctly. If we would apply the correct temperature to each and every fine scan, I'm sure we would stay within plus minus 1.52 millimeters, and that on a range of 1,200 meters. And you see, this is really very, very accurate. And in future, you don't need the large reflector foil targets or cylinders on long ranges. You can really make use of these small prisms, because as you have seen before on that slide, I just jump back here, the prisms occur extremely large. So the prism itself is just around 6 centimeter diameter, but it occurs as a target of 2 meters diameter. So we are getting a lot of measurements on that prism, and we can estimate the center point also with millimeter accuracy. So that's about the prisms. Now let's speak in a few words about automatic registration. I hope you all use already this fantastic tool of full automatic registration also for mining. I want to speak just in a very few words about how automatic registration works. It's a three-step hierarchical process. So the first step is we are using the internal sensors, IMU, GNSS, compass to get a rough estimation of position and orientation. The next step is we are extracting voxels out of the scan data. Voxels are small cubes, looks like a Minecraft landscape, and then we fitting the different scan positions, the different voxels to each others. With that, we get an accuracy of half a voxel size. And imagine the voxel size in mining is normally larger than 1 meter. So the accuracy is maximum half a meter at that point. But for the final adjustment, our algorithm always extract planes out of the surface, is matching these plane patches from different scan positions together, and within an iterative process, minimizing the errors between these plane patches. And then we can really get a millimeter accuracy. But let's have a look on a typical mine situation. You see, these are all the planes we are extracting in an open pit mine. And if we zoom in a little bit, we see, yes, we have here a lot of plane patches, but the size of the planes are quite small. So very few planes from different scan positions are overlapping to each other. And they must overlap to be linked together and handled as one observation, which we are using. So we see in such a feature-poor area, we get almost no observations. These lines are simply indicating matchings and observations between different plane patches. So very few matches here. And therefore, let me just go back to the settings. These were the standard settings with match planes to planes. And now we are introducing a new algorithm which is matching points to planes. The original scan data is matched to the planes. And with this option, you should only use this option in feature-poor areas like we have in mining. With this option, if we go again into that area here with the few observations, if we use points to planes, you see we are getting many more observations, and that makes the final registration much more stable and accurate. And also, if you finally want to use multi-station adjustment as a bundle adjustment between all scan positions to increase again the accuracy, you see that also multi-station adjustment is now supporting this method. So you can choose here either the standard setting planes to planes, or for such a mining area, I would recommend points to planes. So that's about automatic registration. Let's go to the next topic. We are introducing a new voxel comparison tool, which allows monitoring and change detection. I have to explain in some words. Of course, we could already over years doing surface comparisons, but this was always in combination with a lot of post-processing. So we have a scan, we have to filter that scan, we have to create a polydata object. Thereafter, we have to create a mesh, which means triangulating of this polydata object. And once we have two different meshes, we can compare them to each other. So a lot of post-processing steps to get a comparison. But now, with this new voxel comparison tool, we can do it with only 2 mouse clicks. First step is we select a scan and extract voxels with a defined voxel size. This you can use defined by yourself depending on the application. So you select here extract voxels, It's creating this voxel data set, and within each voxel, we are analyzing the scan data. We are estimating a best fitting plane, the standard deviation value representing the noise of the data in respect to the extracted plane, and we are getting also automatically a normal vector for each and every voxel. This with only one mouse click. And then you have created that voxel data set, and then you click on compare with voxels. So now you select another data set, which can be a scan, a point cloud, or another voxel data set. In this example, we have chosen another voxel data set, and we are selecting compare with voxels. And this now compares along the reference data set, along the normal vector of the reference data set, and this gives to this second data set a new attribute, which is called distance to surface, and which is the distance to the closest voxel. And this is an attribute, and you can then open this data set and using this distance to surface attribute to visualize the differences. So you see, with just 2 mouse clicks, you have a new attribute on your data set, which gives you the comparison to a reference data set. Now I want to show you a typical example for that. This is data from a slope in an open pit coal mine in Germany. We have permanently scanned it every 2 minutes. The voxel size was here 0.5 meters. And we can see here already after 15 minutes that the whole area here is slightly going forward. Just a few millimeters. If you are a visual observer, you would not see anything on that slope at this stage. But the scan data, or better the voxel with the distance to surface attribute, is indicating already some movement. And in the next minutes, we see that already some smaller parts are really falling down. But then the next 20 minutes, again, nothing happens. And even at that stage, we are here just a few centimeters of movement. So again, if you would look on that slope, you would hardly detect any changing. And then finally, after 45 minutes after the first scan, the whole slope has collapsed. So this gives us a lead time before the collapse of approximately 45 minutes here. And you can visualize this data and you can remove the machines. You can stop the production just to be on the safe time, because if the machine is covered by the slope failure, it costs you a lot of money. It's a safety issue. People can be endangered. You have to remove the material. Your machines are broken. So this saves you a lot of money. A second example is an underground example. So that could be an underground mining, but in that case, it was a very famous ice cave in Austria. We have scanned it at 2 different epochs, 2017 and 2019, registered the data together, and then simply running this voxel comparison with 2 mouse clicks, and we get immediately in the whole cave an analysis of where the ice was growing within these 2 years and where it was decreasing. And we have here also a nice animation, which is not really working now online, but it shows you again, with just 2 mouse clicks, we have the whole analysis of ice decrease and increase of the whole cave. Okay, that was the new voxel-based tool for data comparison. And now another extreme important tool. I think many customers have waited years for this. Our new geological tool for geotechnical analysis. It's running already on a first beta version, and I'm expecting the release by the third quarter of this year, around September. And this is really a very nice plugin. It delivers directly dip angle and dip direction of the scan data. These results are stored as new attributes on the scan data, but it delivers not only dip angle and dip direction. It can do also a structural analysis by computing stereo plots. You can define the number of classes you want to extract. You can also, it's creating stereo plots, and the classes, the sets which you are creating from that structural analysis are also stored as a new attribute on your scan data. And you see how it works. It's creating such a stereo plot. In that case, we wanted to extract 3 sets. We can define a minimum separation angle between the center point of each set, and we can define the area around the center point, which should be colorized. And again, this goes in as an attribute and can be used within the view type. And this gives you immediately information about joints and faults, because you immediately see the main directions of these joints and faults, and you have full control on how to create the stereo plots, how many classes, how to separate them. So I think this is really a tool many of our mining customers, especially the geotechnical people, have waited for years now, and it will be available in autumn. So that was the first part of our webinar. And now in the second part, we will focus again on the hardware a little bit. So we know that our scanners have a lot of sensors already on board. We have an integrated GNSS. We're offering also RTK GNSS receiver now. We have an inbuilt IMU compass. We have wireless LAN, LTE modules, USB port, SD card slot, all available on the scanner. And of course, we have onboard processing resources to do data processing, data registration. But we have also the hard and firmware architecture for running apps on the scanner, which can directly process the data and deliver final results in real time, directly on the scanner. And on these things, we will focus on this second part of the webinar. The first questions were if you are interested in remote control. Yes, and you see remote control is possible from anywhere at any time via the internet. So we have our RIEGL BZI series app. If we have LTE, Wi-Fi or Ethernet connection via the internet, we can control the scanner anywhere worldwide. So for example, normally the mine is anywhere in the center of USA. Your headquarters is, let's say, in Houston or LA, and you can control the scanner directly from there. If it's a permanent installation of the scanner in the field, the scanner is then acquiring the data, doing already some onboard processing and uploading the data again onto the cloud via the internet back to the headquarters in real time. So this is really already possible. Now let's speak about a typical mine network configuration. I've tried to show it on that slide. Typical network is simply we have a router. Some computers are connected with the router in the mine, and let's say the headquarters far away. There's also computers, a control room, and this headquarter is connected by using any VPN connection, safe VPN connection with the mine network. So of course, this computer has also connection with these other computers. So this is a typical network as it is running in every company. Also at RIEGL we have such a network, and for example we have other office rooms which are far away from the headquarters, and we have also similar VPN connections to get access to our network. So this is a standard network. But what makes a standard network a smart mine network configuration? If we use, instead of a normal router, wireless access points, and if machines and operators are also equipped with connection to that wireless LAN, for example, with a tough book inside the machine to get directly access to the network, and maybe the machine itself is sending data via the network. This is a so-called smart mine network configuration. And it is extremely simple to integrate our scanner in such a network. And I have shown also here a symbol for a file server or NAS drive, because once our scanner is integrated into that network by using the wireless LAN or even the LTE module, or even just a TCP/IP connection to a router which has wireless LAN access to that network. All of these things are possible, and we have a brand new app on the scanner. It's called RSync app for data synchronization. So you see here on that screen, this is the graphical user interface, and it shows that we can mount any file server or NAS drive by just typing in the IP address, defining the folder which is available on that file server with a username and password which gives us access to that, read and write access to that folder, and then you can apply it and mount it, and then it is available as a storage medium on the scanner. But I would not store the data directly on that file server, because maybe of limitations in the bandwidth, you would have some delay in data acquisition. But with the RSync app, you see here, this is the RSync app, and this is the graphical user interface of the RSync app. We still store the data on the internal hard drive of the scanner, but in the background, we synchronize, let's say every 2 minutes or every 1 minute, the data directly with that file server. So you do the data acquisition with the scanner in the field, it's connected with this hotspot, it's storing the data on the scanner, but permanently synchronizing it to the file server. And once you have finished your data acquisition, you can switch off the scanner, and the data is available on the file server, and it is available for the operators in the headquarters. It's available for the operators of the machine. That's the real smart thing. Next slide, we are speaking about our scheduler app. I don't know if many of you have already used it, but if you have a permanent installation in the field, it's simply sometimes necessary to do our schedules, and we are using simple cron scripts. You can read about cron scripts in Wikipedia. It's a very simple syntax with just 5 entries to define very complex schedules. So for example, if we want to scan that area, here, if we want to scan this area, let's say every 10 minutes, we just use the first entry, minute, divided by 10, every 10 minutes, and we leave the others with the star. This simply means every 10 minutes. This area, we want to have a very complex schedule. We want to scan every 15 minutes and 45 minutes after the full hour on the day shift between 8 and 7 o'clock in the evening on weekdays. So it's simple again. For the minute, 15 and 45. For the hour, between 8 and 18, which means 80, 59 minutes. And then the next 2 entries we don't need. And for day of the week, we define 1, 2, 5. Again, a complex schedule with a simple syntax defined. And then a very exotic schedule, but just to show that it is possible, we want to scan that area on every third Friday in November. So we say schedule 00, so we scan at midnight. We don't need the day of the month. We define for month November or simply 11, and day of the week Friday or 5, followed by a hashtag and 3, which means the third Friday within this month. And such a schedule is simply stored in a very simple text file. So you have an example of that text file already stored on the scanner, so you can use that example text file and overwrite it. You have a default section here which defines the project name, the scan pattern, the measurement program, and then followed by the jobs. So you can define an unlimited number of jobs. Job 01 was the one for every 10 minutes. Using, if nothing else is defined within that job, it's using the default parameters here. Job 02 is for that area, but here we change the measurement program, so it's overruling the default section and we're using a different scan pattern. And for job 03, we even define a different project name, and we want to create on each scan every year, because it's not exactly the same scan position. Then we want to create a new scan position. So again, we can define that here and overruling the default section. And this simple text file is stored on the scanner. You start the scheduler app, it's reading the text file and simply performs all these schedules. And now, the last few minutes, I want to speak about the apps. And don't forget about the Smart Mine Network. I leave this drawing here so that you always combine the idea of the apps with this smart network. So maybe many of you have already used the monitoring app for automatic change detection. It can calculate and visualize differences in respect to a reference scan, to the first scan. You can define threshold values for change detections, and these can be flexible defined. So once you start the monitoring app, you define a project, you define a scan position, thereafter you define your timer settings, how often you want to acquire a scan, then you define your detection, change detection settings, low threshold, high threshold, the color table here, and this gives you immediately the comparison between the first scan and the consecutive scans here on the screen. So this monitoring app is already well known, but on the last two slides, I want to show you now really two brand new apps which are just available within the last days. You can ask for these apps. We can provide them to you free of charge for testing and running. The one is the Design Compare app for real-time analysis of undercut and overcut. So starting that app means, of course, you need a registered project. So you run simply with a high accurate GNSS on top, the automatic registration in the field. When starting the app, you have to define a design file, an STL file format. You define the coordinate system of that so that scan data and design fits together. You can define for undercut and overcut the threshold values, again the color table and everything, and then just you start the data acquisition and you see immediately on the scanner here the comparison of the scan data in respect to the design. And now go back to that smart mine network. You are the operator, let's say, of this machine. You are digging the material. And now, let's say you have a simple tough book connected with that mine network, and you just have a simple web browser on your tough book. And by typing in the IP address either of the scanner or the file server here, you get access to the data. It's opening the data within the web browser. You can set markers here. You see immediately the value of the undercut and overcut. You can scan through switch through the different scan positions. You can even print it, and this gives you in real time on the machine in the field the information. How much can you dig? Is it an overcut? Is it an undercut? Because the main thing is you have to avoid overcuts, and you also have to avoid as good as possible undercuts, because this is money. But overcuts is safety, and if you have an overcut, you have to repair the situation in the field so that it fits again to the design, and that costs a lot of money. It's also a safety issue. And this app on the scanner delivers you in real time without post-processing, without any post-processing software, directly the necessary data. And the second app is very similar. It's called Slope Angle app. It does not compare with a design. It simply calculates the slope angle of the scan data. In that case, the data is, there is no need for registration. There is also no need for leveling the instrument because we have the IMU inside. So you just start that app from any point where the scanner just is mounted on a simple tripod. You start that app, you just define your slope coloring settings, your minimum threshold value underneath 5 degrees. We don't want to colorize. Our critical slope angle is 70 degrees. So it's running from blue to red, and everything above 70 in that case is colorized in pink. So these are the critical values. And again, let's say this is a dump area in a mine, and the operator of this loader has a tough book with web browser, and he can see exactly what happens after unloading the material. He sees immediately if the slope is still within the limits or if it's already critical at that position. So this information is available in real time. So let me just summarize and end our webinar at that point. So I hope I could show you that RIEGL hardware is ready for the demanding challenges for smart mine operations. We have seen the onboard mining apps, which allow real-time data processing to optimize your mining workflows. The results, as already mentioned, are available directly via web browsers, no further software required. The apps are free of charge. You just upgrade your scanner to the latest firmware and you can get an installer for the app from us. The RIEGL hardware can be easily integrated in any mining network configurations, and the scanners can be remotely controlled. So I think all these things are really supporting the idea of the future smart mine, where we have less people working in dangerous areas. We have more robotic applications. We have operations, remote operations, and we are getting real-time information. And you see our hardware and software is already prepared for that. So thanks for your time. And now we have also some time for questions, and I try to give answers. So if you want, you can just type in your questions and I try to answer it. Make use of this possibility, or if we don't have enough time for answering the questions I mentioned already before, you can send your questions also directly to info@riegelusa.com, and of course we will try to answer all these questions. Okay, just some positive feedback is coming at the moment, but not a real question. I give you just another minute. And again, thanks for spending the time with me. As I have seen from the list, from the registered people, we have attendees from worldwide, so not only from USA, Canada, from all over the globe. I think for some of you it's around midnight, so thanks for staying and joining us. Apps apply. There is one question. Apps apply to VSAT 4000 system. This is a limitation, I must really say. That the VSAT 4000 scanner has an older architecture, so there is no possibility to run our apps on the VSAT 4000 and 6000 scanners. So apps and post-processing tasks which run automatically on the scanner are just available for the VSAT I series scanners, the VSAT 400i and the VSAT 2000i. Okay, just some feedback also from Chile. Thanks and greetings to Chile. Okay, I think if there are no further questions for the moment, just think about this webinar, make your own ideas how you can make use of such a system in a smart mining network and what kind of apps would be interesting. Maybe one important thing is to mention, of course, we are developing apps and we provide these apps, but in principle, it's a real open architecture. So every programmer with Python scripting knowledge and C++ programming knowledge can develop his own apps. So that's also an option for the future. So not all the apps will be developed by RIEGL itself. Okay, so then thanks again for joining this webinar. Hope that we have further webinars in close future. And of course, I hope to see you soon on a real conference once this strange time of Corona has passed. And I hope we all stay healthy. And then I hope to meet you personally. Thanks a lot and goodbye.